reminders for you. First off, you have plenty of homework out there that you should be doing. You have the pink sheet that you got yesterday. You have the 2 assignments that are over on the side board that you got earlier this week. You've got other things hanging out there too, but they have their own bullet coming up. Okay. Today when you came in, you picked up a white sheet, Intro to Logs sheet. There is a video on It's Learning about that. That note sheet will be collected during your 4-mod day. Okay. We are having an issue with people not watching the videos, which is not an option. Okay? You need to watch the videos because that's the whole part of blended learning. Some learning you do here in the room, some learning you do outside, at home, at Starbucks, etc. Okay? And the last time we had you watch videos, it was about less than 50%. There's like 144 kids in pre-calc right now, and it was at 59. Watch the videos. Okay? So, not good. Okay? So that will be collected on your 4-mod day, that white sheet. Okay? Very shortly, if it's not open already, there will be an online formative assessment. It is 4 questions long. It must be completed by Wednesday. Okay? It's on It's Learning. It's in the resources, and it's the very first thing. It's the top line under resources. You have up to 3 tries at it. Okay? It is not a fixable one after Wednesday. Okay? Because it's online, you have 3 chances to get a perfect score of 4. Okay? If you don't, then we take whatever your highest score is if you did it. If you didn't do it, then you get a 0. Okay? So that is online. Got to be done by Wednesday. There's a bank of questions, so every time that you take it, it will be different questions. Sometimes it might be the same questions, but it'll be different questions, different order, and all that stuff. Last week, or I should say this week's 4-mod class, we did the exponential dice. We will be collecting that on Tuesday. Or I should say during your next 4-mod class. Okay? We will give you time to work on that one during that 4-mod class. Okay? But it is collected, or we are collecting it. Okay? And then we have scheduled the test for exponentials, logs, and logistics on the 24th of October, which is the Wednesday before the long weekend in October, because you're at school on the 25th, 26th. Okay. Questions on any of that? Awesome sauce. Yesterday, we were dealing with logistic functions, and we were dealing with nice ones. We had a nice A value, we had a nice C value, and we could easily find our B value. Unfortunately, logistic functions are not always nice and pretty. All of the processes, if you will, are the same. But the numbers might be ugly. Okay? And I'll show you a way to get around that a little bit later on. So, here is the the logistic population growth of Dallas, Texas, T years after 1900. Okay? Using some kind of a calculator, please find me what the population of Texas was, or excuse me, of Dallas was in 1950. So, how am I going to do this problem? How am I going to do this problem? Plug in 50 for T. So it's really just a lot of button pushing. So I get the population of Dallas, Texas. Everything's bigger than Texas. Is 477,000. Now I lost it. 498. Agree? Okay. All right. Fantastic. Next question. When did or when will the population of Dallas, Texas exceed 1 million people? How are we going to do this one?
Did you graph it?
What am I going to graph?
The equation.
Okay. And
then make another equation, put a thousand or a million.
put a million in. Let's make it happen. So on the graph, we put on our function. But what should I do? Instead of t, x. Because it's a function of x. Okay? And then I should put in a million. Ruh-roh. What's wrong with that? Got to zoom out, right? So instead of zooming out, because we could be zooming out for a while, how about we just go through and we just change our window? Would that work? Okay. So menu, window zoom, window settings. Okay. X's, we can stay at -10. That's fine. Maximum, let's go 150 just in case, just so we figure out when it is, because that would be 2050. Okay, let's go with the scale of, we'll go with 15s. Could be anything there. -50,000 there. I need to go bigger than 1 million. So let's go 1.5 million. I'm going to go by 50,000. See where they intersect. So that's a menu, right? Analyze graph, intersection, and they intersect right there. So when did Dallas, Texas's population go over 1 million? When in 1984? When in 1984? What's the middle month? June. Sometime around June. Okay. Last question for this one. What is Dallas's maximum sustainable population? What is the maximum sustainable population of Dallas, Texas? Everything's bigger than Texas. We got script? Nope. Go ahead. So my C value, which was what? Well, it's on your calculator. Or you could look up here. That one. Okay. Good. All right, let's revisit Pennsylvania. Okay. We said yesterday that Pennsylvania was logistic, right? Okay. And I gave you a scatter plot of Pennsylvania yesterday. Okay. But what I would like you to do now is I would like you to create that scatter plot of Pennsylvania. Because we're going to put our logistic function right on there. So how do I go about creating a scatter plot on the graphers? Anybody remember? Lists and spreadsheets. Yep, I need to create a spreadsheet with my data. First off, I've got to title it. I'm going to go year and pop for population. Okay. Now, do I want to use 1900? No. Okay. What should I use for my first data point? 19? 0. Yep, I'd go 0. And then so it would be 0, and then 10, and then 20, and so on. All the way down to 100. Then, under my population column, what? The corresponding population, right? Okay, fill those in. everybody got their spreadsheet made. Okay. Now what you're going to do is you are going to open a new page. And it's going to be a graph. But we don't want it to be a function. We want it to be a scatter plot. So I'm going to go into Menu, Graph, Entry, Edit, and number 6 is scatter plot. Then it's going to ask me what I want for my x's, and I can type in my column. My column title was year. When I finally get it typed in right, it will go bold. If I screwed up and I went years, it will not be bold. Okay? So it will tell me that I make sure I have a column listed like that. And my other one was pop. But now what do I need to do? See the rest of it, right? So I only see one data point. So let's -5, x max. Oh, let's go out to 150. By 15s again. Y's, we don't have to go that tall. Exactly. Yummy. Okay, so there's our scatter plot. Everybody got that? Okay. All right, now what we need to do is we need to find our A, our B, and our C. So we need y equals C So, do I know my C? Do I know it? No. So I got to set it. Okay? Because I don't know it. So I got to set it. So let's come up with a C value. That's going to be the limit to our growth. Yep. So it's got to be bigger than 12.3. Right? Right? Yeah. What? Well, but
like, is that like?
because remember, it's only going to reach the limit when it's at infinity. So infinity is not in the year 2010. You know what I mean? So I wouldn't go at 12.4. 14? Do we agree with 14? Okay. Okay. A little bit bigger than 12.3 because we could still probably add some people. Okay. All right. So C is 14. What does this point signify? No.
It's the y-intercept.
It's the y-intercept. So what is that point? 0, 6.3, right? So let's use that. 6.3 is going to equal 14.0 divided by 1 plus a b to the 0 power. B to the 0 power, 1 times a. So this is really 6.3 equals 14.0 over 1 plus a, right? Okay. So yesterday, what we did is we went 6.3 times 1 plus a equals 14.0, right? Then what did we do? Nobody should be calculating anything yet. Then what did we do? Divide by 6.3. So that's going to be 1 plus a equals 14.0 divided by 6.3. Right? Then what? What? Then we subtracted 1. Now here's why I said don't calculate anything. We're going to store that because yesterday they were nice values, right? This one, not so nice. So we're going to store that on our calculator. Here's how we're going to go about doing that. I'm going to go back into my calculator page. And I am going to type in, this one should go down. And I am going to type in, no, I can't see it, that 14.0 divided by 6.3, then minus 1. Now that's my a value, right? So I'm going to store that on my calculator. So I'm going to go Control var, that one. Okay? Control var is the stow key. And what do I want to store it as? A. And now, until the batteries run out, or until we start a new document, A is going to be 1.2 repeating. Okay? Alright? But we can just leave it as A. Okay? Now what do we have to find? B, right? So now I've got to go back and I've got to look at my graph. And I've already used that point right there. I've got to come up with a different point, probably a little further on down the data. Okay? So I'm looking at this one. Yes? Okay. Well, which data point is that? 0, 10, 20, 30, 40, 50, 60, 70. Yes? Okay. So, use our 1970 data. Okay. So that is the point, what? $70, 11.8. So 7. Why did it stop working? 70 is going to equal, oops, that should be black. Hold on. Issues. Right? Not pretty. Because we're already going to have to take a 70th root. Okay? That's okay. That's why we have calculators. Okay? Alright? And A is already stored on our calculator. So let's write all this out. So 70 times 1 plus A, B to the 70th is going to equal 14.0. 1 plus A, B to the 70th is going to be 14.0 divided by 70.
Why does it equal 70?
Oh, sorry, that should be 11.8. My bad. I was getting all jazzed up with the 70th root. So what is this? 11.8? That one? So 11.8 here times 1 plus A, B to the 70th is equal to 14. Plus AB to the 70th is going to equal 14 divided by 11.8. Subtract 1. Then what? Divide by A. And then what? 70th root. Okay. Oh yeah, plenty of time. So, back to my calculator page. The 70th root of 14.0 divided by 11.8 minus 1 all over A gets me that. I'm going to store that as my B. Okay. And then, now I can go into here. I can change my entry back into a function, and I can type in my logistic function. 14 divided by 1 plus A, B to the x power. Oops, I need a multiplier there.
and there is my function.
Okay. We'll do more of this next week.